Hello friends, welcome to another session on operating systems. Now let's get into the second part of the module 1 where we look into the various services available with the operating systems. So let's jump into the operating system services. Just before getting in detail about the services, let's just quickly look at what operating system is. The operating system is an interface between the user and the player to make the user's actions simple. The operating system is the one which gives a abstraction of the hardware to the user, makes the life of the user simple, and makes all the devices connected to the hardware work appropriately and more efficiently. So here we have hardware. On top of the hardware, we have an operating system, and then on top of that, we have application programs, and user is allowed to interact only with the application programs. User is working in the user mode, and other important activities only will be working in the kernel mode. The user can interact with the application programs, like a user can open a Word file or open a Word document or any such thing. So that's an application. And when user tries to open a Word document or the Word program, then the Word program will interact with the operating system, and the operating system in turn will provide a space for the program to be stored onto the main memory and becomes a process, and appropriate memory is allocated for the code, for the data, for the stack, and all other things. So all these services are provided by the operating system, and operating system is hiding the real hardware from the users and the application program, and makes things simple. So we don't have to bother about what hardware we are working with. Is it a Intel processor or is it a Mac processor or anything? Can be anything. Doesn't make any sense. Operating system takes care of what is behind in the hardware. Doesn't allow or doesn't make the user to bother about all that. Even the application programs also don't have to worry about what hardware on which they are trying to execute the application programs. So this operating system is taking care of all that. So that's a operating system. It's an interface between the user applications and the hardware, and makes the things more efficient, smooth working, and all that. So that's a role of operating system in a computer systems. So the various examples of the operating system, it may be Microsoft's Windows. Started with a disk operating system. Now we have Windows. Apple's operating system. We have Mac operating system. We have Linux operating system. We have a version of the Linux operating system, Ubuntu. Then on the server side, we have Windows servers and all. So many versions are available. Many companies are coming out with many versions of the operating system. So these are some examples of the operating systems. And operating system is mainly meant to provide a user interface with the system. We had began our journey with a command line interface where every information is given to the machine through the keyboard. So it was only the command line interface through keyboard it was possible, and every activity we had to work only through keyboard, and It appears to be too hectic for a common man. So to make the things simpler for the common man, the graphic user interface was introduced in the Windows and later versions. Under DOS, it was only the command line interface, but Windows onwards, we had a graphic user interface and make the things easier. Just a click away, instead of typing everything, we can just click the mouse and scroll and all that. So the things have become simpler because of the improvement in the operating systems. Now let's look at how the users interact with the system through the operating system. So users are directly allowed to work with the system softwares, application software. So we have two types of softwares. One is the system software which control the configuration of the system and all that. Application softwares are the applications provided to the user. So user usually is connected with the application softwares, and these application softwares will make the life of the user simple, will give most of the template available, only fill in few uh, missing gaps. So that way things become simpler because of the application softwares. And these application softwares will interact with the operating system. Operating system doesn't allow the system software or application software to look into what actual hardware is and all that. So the whole interaction between the user and the actual hardware is done only through the operating system. So one reason for that is giving abstraction to the user or to the application, so that what actually the hardware is, the application don't have to bother about, the user don't have to bother about. It's a operating system which takes care of all this. And next thing is providing a proper protection and security to the system. So the users uh, will not be allowed to directly interact with the hardware, so that they can create some sort of problems. So whatever the user wants to do has to do only through the operating system, and operating system will allow only the valid operations from any user. So thereby protection to the system and security to the data and the files is provided. The various services provided by the operating system to the users. So the important service provided is in executing any program. So the program, what we call a code, is called a program as long as it is in the backend, that is a secondary drive. But when you try to execute that program, when you want to run the program, it comes onto the main memory. On the main memory, that is the RAM, and once it comes onto the RAM, there is code for that, and there is memory reserved for the data, there is memory reserved for the associated stack and all that. So all the memory together will become what we call a process. So it's a live one which we call a process, and this process is executed by the operating system. So main purpose of having operating system is to execute any program. So in this we have the program on the RAM, and the CPU interacts with the RAM, and one time one operation is performed. So it fetches one opcode of the code for one operation. So each operation is given a code which we call opcode, and the opcode is fetched, and if that opcode or that operation needs some data with it which we call operands, then it will fetch the operands from the program and then makes the execution possible. It executes the instruction and the results are stored appropriately. So one instruction at a time, it just takes on and runs the process. Next important activity done by the operating system is about the IO operations. So as we discussed earlier, that whole system is interconnected through what we call bus arrangement, because we know that there is one processor and one processor can anytime interrogate or can send or receive data from one of the IO devices, not more than one. Therefore, there is no point in connecting each IO device separately to the processor. So what we can do is we can connect all of them in parallel to the bus, and whichever device is to be used, only that particular device is kept live and all others are put on sleep mode. So only one of the devices will be active and all others will be made forced to be inactive, and communication between the CPU and the IO device takes place through the buses. So all these operations are performed through the operating system. So operating system will take care of all these operations and ensures the addressing of each of these IO systems and all that is taken care by the operating system. So that's what we call IO management of the operating system. Then it's what is about the file system. So there we do have at a highest abstraction level what we call application program, and then it becomes a logical file system. Then it goes into the file organization module, then the basic file system, then we have IO control, and finally device. So somewhere in the secondary drive this file has to be stored. So where it has to be stored, so that is exact at the device level we talk. Then are we storing or receiving, then what format we are trying to do, and that all IO control we have, which sector, which track and all that if it is a hard drive. Then we have a basic file system, what the file is, what file consists of, and how the file is defined, structure of the file and all that, and then file organization, that means directories and all that. So this whole system is taken care by the file system or file management system of the operating systems. Then takes care of communication and error detection and all that. So there is the sender, there is a receiver. The sender sends the data, receiver receives the data to make sure that nothing wrong happens on the way between the sending end and the receiving end. We do have something called error detection. So we have error detection, error correction facilities that's provided in the operating system. So the two systems can communicate with each other. So for communicating, we do have some standards defined, what we call as protocols, and then protocols will define the standards, how the data should be transferred, what way the data should be transferred, and all more details will be defined in the protocol. And when the communication is taking place and when the file is received from the transmission line, then we need to verify whether the received file is intact or done something wrong. So for that some error detection techniques are there. So one option is just detect the error. If it is whatever you received is error free, then use the file. If it is having error, then you can request to send it again. If resending is possible, then there is no problem. But if resending is not possible, then the whatever we have received, we should make sure to use it. So we need some more stronger version of error control, which we call error correction. Yeah, correcting an error needs a lot of logic, but detecting an error is simpler compared to correcting an error. So, if retransmission is possible, then better go for retransmission and just check whether the file received has error or not. If it has error, ask for retransmission. No error, use it. But in some cases, like we are getting the data from the satellite and all that, which we cannot get again and again, like weather data or any such thing, then only once it is possible to receive the data, then we should somehow use it. So we should be ready to spend a lot of resources on that to correct if we receive the data with error and all that. So that's all the operating system will take care of. So there are some services for system efficiency like resource allocation, then accounting, then protection and security. All these details we are going to look in coming sessions.